Good morning, guys. How are you doing? We're going to do radical equations. It's section 4 of your book in chapter 10. Pretty easy concept. Basically says if x equals y, then x squared equals y squared. Okay? Not super difficult. This is how we're going to use it. If they gave you something like, I don't know, what's their first example they give you? Square root of x equals 4. The way to get rid of that is you square this and you square this, so we can do the same thing to both sides. That gets rid of that, so you end up with x, and that equals 16. Okay? Why don't we do a sample from your book? Example 2 from your book says a plus 5, or the square root of a plus 5, plus 7 equals 12. Well, we know we're eventually going to have to get rid of that square root. And so we would like to just kind of square this. The problem is that's kind of messing things up. So let's get that to the other side. Let me make sure you can see here. We're going to move that to the other side first and just leave the radical sign behind. Square root of a plus 5. Move that over and subtract it. Equals 5. And now at this point, we can square this and square this. So that takes this away. You're left with a plus 5 equals 25. Take the 5 away, a equals 20. Do you see how that worked? Now, one thing I have to say is when we do solve things by squaring like this, it occasionally gives you a weird answer. They're called extraneous solutions. So we always have to check and see whether it works or not. So take the 20, put it in here. 20 plus 5 is 25. Square root of 25 is 5. 5 plus 7 indeed equals 12. So we're okay. Let me show you one that does have an extraneous solution. This is going to be example 3 from your book. It says the square root of k plus 1 equals k minus 1. So we've already got the radical isolated, so we're going to square this side and we're going to square this side. That takes that away, so we end up with k plus 1. And remember, this is a binomial squared, so we square the first one. We multiply the two together and then double it for the second term. And then we square the last one. At this point, we're going to simplify, get everybody on the same side. So let's leave k squared there, and we'll move that k over and subtract it. And we'll move that 1 over and subtract it. So it'll be k squared. And if when we subtract that k from that, negative 2k, we'll end up with negative 3k. And when I subtract 1 from 1, I get 0. So that's simplified. Now, I see that there's a common k here. Let me make sure you can see this. So let me factor that out. K times k minus 3 equals 0. Now I'm kind of set up to do the zero product property. So either this equals 0 or this equals 0. Well, so I'll write k equals 0. That's one of my answers. And then if k minus 3 equals 0, when I solve that, k equals 3. So there's my two answers I get by solving it. Now I'm going to have to go back and check these. Before I squared it, this is my original problem. So let me put both these in here and check them out. If I put 0 in here, 0 plus 1 is 1, the square root of 1 is 1, and 0 minus 1 is negative 1. That does not work. So 0 can't be one of my answers. Let me try 3. 3 plus 1 is 4. The square root of 4 is 2. And 3 minus 1 is 2. So 3 is a valid answer. Okay? So do you see how that works? When you get done solving things this way, just simply go back and check. It doesn't take very long, and you'll see whether you've done it whether you have an extraneous answer or not. Okay, that's it for solving radical equations.